Okay. May, June 2023, paper 1, variant 3. يلا. Hmm. Question 1. Which piece of apparatus is used to measure the length of a copper rod and the length of approximately 2 centimeters? A length of approximately 2 centimeters. Which piece of apparatus could measure the length? Huh? Definitely not a timer, not a cylinder, and not a balance. أكيد a ruler. Definitely, yes. Hmm. How far does the object travel at a constant speed? يلا. Speed time graph. Okay, speed time graph. How can I measure the distance traveled? How far does the object travel? Distance, yes. Okay, distance traveled is the area under the graph. Yes, area under the graph. And the area under the graph for the constant speed. Where's the constant speed? Only this area. Okay, the area of this square or rectangle. Length times width. Length times width. Yeah. Length is from 5 to 15, which is 10. 15 minus 5 equals 10. And the width is from 0 to 5, which is 5. Yeah. 10 times 5 is 50 meters. Length times width. Okay. Hmm. Yeah. A rock falls off a cliff onto a beach. The effect of air resistance is negligible. Which row describes the acceleration of the rock as it falls? While the rock is falling, what's happening to the acceleration and what's happening to the speed? As the rock falls down, yeah, I need some answers. As the rock falls down, okay. As the rock falls down, what happens to the acceleration and what happens to the speed? Hmm. Can the speed be constant? Yani, can the speed be constant? Definitely not. The speed cannot be constant. Definitely, this would be wrong. The speed is increasing. Okay. What about the acceleration? Question is the acceleration constant or is it increasing? Hmm. Is the is the acceleration constant or is it increasing? Okay. Okay. لا. Actually, okay, most of you were right. It is constant acceleration. The acceleration cannot be increasing. Why is the acceleration constant يا شباب? Why is the acceleration constant? Because it's 9.8 meters per second squared. This is the acceleration of free fall, okay? When you throw a rock or an object or whatever, or if you jump from a plane, for example, if you decide to jump from the plane, okay, as you're falling, the acceleration equals 9.8 meters per second squared. Okay, that's the acceleration of free fall. Okay, okay, yeah. Two rectangular blocks consist of different materials. We have different materials. Four different methods are suggested to compare the masses. We need to compare the two masses of these blocks. One, compare the accelerations with which they freely fall. Compare the values of their lengths, breadths, and heights. Breadth is width. Okay, breadth is the width. Hang each in turn from a spring. Compare the extensions. Place one in the right-hand pan and the other in the left-hand pan. Which of these methods could compare the masses? We need to compare the masses. Yes. Which of these could compare the masses correctly? Okay. Which of these could compare the masses correctly? Okay, 4 is correct, but it's not 4 only. Okay, 4 is correct. Yes, 4 is correct. But actually, 3 is correct as well. Why? Because we can compare the masses by using the springs. And Mister, we're only comparing the weights. We're only comparing the forces if we use the spring. Yes, if you compare the weight, can you find the mass using the weight? Yes, I can find the mass using the weight. So if you find the weight, you will find the mass. So you can compare the masses, you can compare the weights using a spring, and you can compare the weights or the masses using a beam balance. So 3 and 4 only. Okay, 3 and 4 only. Okay. Next question. Measuring cylinder. Okay, a measuring cylinder containing 50 centimeters cubed of water is put on a balance, a solid object, okay, and the water rises to 75 centimeters cubed. What's the density? Okay, how can I find the density? Why is one wrong in the previous question? One wrong, one is definitely wrong because you don't need to find the acceleration as they freely fall. Again, we just said this question actually. We just said this answer. As they freely fall, they both have the same acceleration, 9.8 meters per second squared. They both have the same acceleration, so you won't be comparing anything. Okay, they're the same acceleration. Question five. Can I find the density? Yes, I can find the density. We know that density equals mass over volume. For this question, we need to find the difference in the masses and the difference in the volumes. So the difference, by how much did the mass increase and by how much did the volume increase? By how much did the mass increase? M2 minus M1, which is 210 minus 150, divided by V2 minus V1 75 minus 50 صح. Okay, it's as easy as that. Yeah. 60 divided by 25, I guess it would be 2.4 صح. 2.4 grams per centimeter cubed. يبقى all we did was we found the difference in the masses and the difference in the volumes and we just divided them by each other. Okay. Any questions? ولا شباب any questions؟ Yeah. A cyclist is traveling in a straight line at a constant speed. A constant driving force acts on the cyclist in the forward direction, as shown. Which statement about the magnitude, يلا شوف. Which statement about the magnitude of the frictional forces acting on the cyclist is correct? If you have a forward force F directed forward, okay, or directed to the left or whatever, what is the magnitude of the frictional forces? He's moving at a constant speed. You have frictional forces acting in the opposite direction. Frictional forces acting in the opposite direction. Definitely, yes, you are all correct. It has to be equal to the magnitude of F. Why? Because he's moving at a constant speed. Okay, whenever you're moving at a constant speed, the forward force, for example, if it was 1000 newtons, then the frictional forces have to be also 1000 newtons. Okay. Hmm. Any questions? Mm. This is a really interesting question. Really nice one. Which distance, okay, you have a beam pivoted at A, which distance is multiplied by the force to give the moment about P? Okay, you have P, which is the pivot. You have a force. Can someone remind me, how do we calculate moment? Moment equals, moment equals what? Force times what? Is it times any distance? Can it be times multiplied by any distance? No, it has to be multiplied by the perpendicular distance. It has to be multiplied by the perpendicular distance. Yes, thank you. Which of these is the perpendicular distance to the force? Which distance, A, B, C, or D, is perpendicular to the force? Yes, correct. You are correct. It has to be A. And why is it 8? Because it's perpendicular, 90 degrees. This is 90 degrees to the force. That's it. Okay, that's it. You need to find the force and the distance which are perpendicular to each other. That's it. That's how you find the moment. That's how you calculate the moment. Okay? Moment equals force times perpendicular distance. Any questions? Hmm. Okay. Hmm. حلو. The diagram shows an unbalanced rod. Okay, this rod is not balanced yet. The rod turns in a clockwise direction as shown. Which action could make the rod balance? Which action could make the rod balance? Now it's moving in a clockwise motion or clockwise moment. How can I balance this rod? How can I need to, you need to decrease the clockwise moment. So you need to decrease the clockwise moment, huh, or you need to increase the anti-clockwise moment. Uh, It's either or. You need to increase the anti-clockwise moment or decrease the clockwise moment? Type. Let's check out the answers. Let's check out the answers. For example, A, if I move X to the left, okay, if I move X to the left, what will happen? Okay, if you move X to the left, what will happen? The anti-clockwise motion, or anti-clockwise moment will increase. If you move X to the left, the anti-clockwise moment increases. Is this what I want? Yes, it is what I want. Okay, you actually need to increase the anti-clockwise moment. Okay, a lot of you are saying C. So let's check out C. Okay, I'm telling you that, oh, no, A is correct. But let's check out C. Okay, maybe C could be right. Maybe it could be wrong. Okay, moving Y to the right. If you move Y to the right, what would happen? Which type of moment would increase? Again, if you move Y to the right, which type of moment would increase? The clockwise moment. Okay, the clockwise moment would increase, which is wrong. Why? Because again, it's already turning in a clockwise moment. Okay, it's already turning in a clockwise moment. You need to decrease the clockwise moment. If you move Y to the right, okay, the clockwise moment. Actually, if you move Y to the left, it would have been right. If you had moved Y to the left, it would have been right. But there's no answer. Okay, none of the answers says move Y to the left. خلاص يبقى we can't move Y to the left. You can only move X to the left, which would increase the anti-clockwise moment, which might balance out the rod. Hmm. Any questions? Hmm. Is it clear now? I hope it's clear now. Hmm. Okay. Question 9. X clockwise. X. Uh, what? If you move X to the left, the anti-clockwise moment will. Why will the anti-clockwise? Because now X is exerting a force downwards, and the force times the perpendicular distance would cause an anti-clockwise moment. If you increase the distance, then you are increasing the moment. Which type of moment? You are increasing the anti-clockwise moment. Okay? Yeah. Okay. Hmm. Next question. It's important that an electric table lamp with a lamp shade does not get knocked over easily. Okay. Uh, you need to increase its stability. You need to increase its stability. How can I increase the stability? Which statement is correct? The center of mass must be as low as possible. Okay, yes, this is correct. The lamp must have a shade which is heavier than the base, the shade heavier than which is completely wrong. Actually, you need the base to be heavier than the shade. The lamp must have a narrow base. No, you need a wide base. The lamp shade must be wide. No, the base must be wide. So A, yes, A is correct. Okay. Hmm. Again, you need to increase the stability. A bicycle braking system transfers energy from a kinetic energy store to an internal energy store. A motor converts energy from a chemical energy store to a kinetic energy store. What enables these energy transfers? What enables these energy transfers? The braking system, okay, converting from kinetic to internal. What is the type of work done? And the chemical energy in the battery to kinetic energy in the motor. What type of work is being done? Hmm. Can someone help me out? Yeah. Okay. Braking system, yes, it has to be mechanical. Yes, the braking system has to be mechanical. Okay, why? Because you're exerting some force over some distance, okay, or you're exerting some force due to the brakes, which converts this kinetic energy into internal energy or thermal energy. Okay, due to what? Due to the friction. Okay, no, okay. Chemical. What about the chemical? The battery. How can the battery produce kinetic energy inside the motor? Yes, it's due to the electrical work done. When you connect the when you connect the battery to the wires, what happens? electricity is produced, electrical energy is produced. So basically, you're changing the chemical energy to electrical energy and then to kinetic energy inside the motor. Okay. الباتري, yes, the battery does store, yes, the battery stores chemical energy. Okay. When the battery stores chemical energy, what's the energy produced? Okay, you need to think about it. What's the energy produced when you connect it to wires? Okay, the positive terminal and the negative terminal. What happens when you connect the battery to the positive to some wires? Okay, it produces electrical energy. So basically, electrical work is being done. Electrical work is being done, not mechanical work. Can you actually see anything moving from the battery? Can you see the battery itself moving? Can you see the wire moving? Can you see, for example, the electrons moving inside the wire? No, you can't see them. Okay. But you actually know that there's electricity, that there's a current passing through the wire, which we can call electrical work done. Okay. We can name this work being done, electrical work done. Okay. To be more specific. Okay. Question 11. A toy car is pushed a distance of 2.4 meters with a force 460 newtons. How much energy? Again, we can calculate energy, which is work done, equals what? Equals force times distance moved. Force times distance moved. 460 times 2.4. 460 times 2.4 would be 1,100 joules. Yeah, quite easy. The engine of a motor vehicle develops a large power. Motor vehicle that develops a large power. Which statement is correct? Power. Which statement is correct about the power of a motor? The driving force acting on the vehicle must be large. The engine must have a large volume. Doesn't have to do with the volume. The engine must transfer large amounts of energy each second. It has to do with the time. Energy per unit time, which is the power. Power equals work done over time or energy over time. Yes, it has to be C. Okay? Large amounts of energy each second. Energy per unit time. That's quite easy. Question 13. A solid cube has sides of 0.5 meters, okay, and the mass of 120 kilograms. Which pressure does the cube exert on the ground? How can I find the pressure? How can you find the pressure for this question? Pressure equals what? Hmm. Pressure equals force over area. Okay, good. Pressure equals force over area. What's the force? Hmm. Can you say 120? Is this the force? Can someone say 120 kilograms? This is the force? Definitely not. To find the force, which is the weight, let me write it down here. The weight equals mg, which is 120 times 9.8. This is the force. This is the weight. Yeah, weight. Well, 120 times 9.8. What about the area? What about the area in contact? Can I find the area in contact? Is it 0.5? Okay. Some of you will say that it's 0.5 times 0.5 times 0.5. Is that right? No, that's wrong. You cannot multiply it. Okay. You cannot uh multiplied by itself 3 times. That's finding the volume. You don't need to find the volume. You need to find the area of the square. You need to find the area in contact with the ground. So it's only area is what 0.5 times 0.5 squared. You only need two sides. You only need two sides. So 0.5 multiplied by 0.5. So 120 times 9.8 divided by 0.5 times 0.5, which is basically 0.25. يعني. What would the area be? Okay. What would the area be? Can someone help me out? Around 4,700. Yes. 4,700 newtons per meter squared. Okay. Again, pressure equals force over area. You cannot use the mass. Okay. You cannot use the mass. You have to find the you have to first find the weight multiplied by 9.8. What What is the lowest possible temperature? Absolute zero. And what happens to the energy of the particles at this temperature? What's the absolute zero? Hmm. Absolute zero. It definitely cannot be C or D. Yes. Huh. Negative 273. Particles have the least kinetic energy. Yes. Particles have zero gravitation. Yeah, يا جماعة, it doesn't have zero gravitation potential energy. Has zero or the least kinetic energy possible. That's what we call absolute zero. Absolute zero, least possible kinetic energy. Which statement about the particles of a substance after condensation is correct? Okay. After condensation. Which statement about the particles? They are close to each other and slide over each other. After condensation, gas to liquid. So after condensation, they become liquid, so they are close to each other and they do slide over each other. This is correct. A. Okay. Hmm. Um, Question 16. Which methods of thermal energy are the silvered walls designed to reduce? The silvered walls. What are they designed to reduce? That's really interesting. How can yes, okay, the silvered walls can reduce the radiation only. Yes, the radiation only. Okay. If he had asked about the vacuum, he would have said conduction and convection. But the silvered walls, okay, reduce. They do not stop. They only reduce the infrared radiation lost. That's why we say, silver is the worst emitter of infrared radiation. Okay, worst emitter. It still emits. Okay, that's why we say it reduces the infrared radiation lost. It doesn't stop. The only thing that's stopped is the conduction, convection in the vacuum. And that's it. Okay. Next question. A drop of water from a tap falls onto the surface of some water in constant depth. Water waves spread out. They spread out on the surface of the water. Which statement is correct? On the surface of the water. Okay. On the surface of the water. What's the type of waves? Can someone tell me? Are they longitudinal or are they transverse? Are they longitudinal? Yes, they definitely are transverse. Okay. And travel the same speed or more quickly in one direction than the others. Hmm. The same speed or more quickly? Yes, definitely at the same speed. But how did you know that it's the same speed? Okay. How do I know? How can I make sure that it's in the same speed? By checking the distances. Okay. By checking the distances between each wavefront and the other. They all have constant distances. Okay. Whenever they have constant distances, water is at a constant depth, so the water waves will move at the constant at a constant speed. Okay? Okay. Hmm, Good. Um, ماشي. Next question. 18. The optical image formed by a plane mirror is the same size. Which row describes the other characteristics of this optical image? Okay, formed by a plane mirror. The distance from the mirror. Hmm. The distance from the error, from the mirror. And is it real or virtual? Okay. Distance and is it real or virtual? يلا. Is it real or is it virtual? يعني real ولا virtual? Real ولا virtual? Definitely it is virtual. Any image, okay? Any image formed inside a mirror has to be virtual. Okay. طيب, the distance from the mirror, is it the same or is it smaller? Definitely it's the same. It's quite easy. Any image forming on the mirror has to have the same distance and it must be a virtual image. Hmm. Any questions? Yes. Hmm. What's the nature of the image formed by this lens? What's the image formed by this lens? Yeah. Any ideas? Huh. طيب. First of all, first of all, is this image upright or inverted? Hmm, It has to be inverted. Okay, so it cannot be upright. Okay. Is it okay? Is it enlarged or is it diminished? Is it enlarged or is it diminished? Actually, it is enlarged. Why is it enlarged? Yani, why is diminished wrong? Why is diminished wrong? Because whenever you have the object quite close, okay, quite close to the focal point, quite close to the lens, okay, okay, again, this object is quite close to the lens. Why? Because the object is spaced at 3 centimeters and the focal length is at 2 centimeters. So whenever you have, okay, whenever you have the object which is quite close to the quite close to the lens, okay, yes, it is behind the focal length. Okay, okay, it has to be behind the focal length, which is it's okay. Okay, it is behind the focal length. But if it was very far away, for example, like at this position, okay, this could be considered to be far away. If the object is far away, then the image would be diminished, then the image would be smaller. But in this case, the object is close. The object is close to the lens. Whenever the object is close to the lens, what happens? The image becomes larger. Okay, the image becomes larger. Okay, it has to be large. Inverted. Okay, what about the image? Is it closer or is it further? Actually, the image becomes further away from the lens. Okay, the image will appear somewhere around here, for example. The image will appear somewhere around here. Okay, you can draw it if you want. Okay, if you want, you can draw using a ruler. You can continue the line which is passing through the center. Okay, you can continue this line. I guess it would appear somewhere here. It doesn't matter again, but the image will be enlarged, inverted, and it will be further away. Okay, it will be further away. Whenever you have an enlarged image, okay, an inverted enlarged image, it will be further away from the lens than the object. Okay, yeah. Okay, we solved this question before. White light, it splits into some colors. What could these colors be? What could these colors be? One, two, and three. Yeah. What could these colors be? Hmm. Yeah. Roy Gibiv. Yes, Roy Gibiv. So the only answer would be C. The only correct answer would be C. Yes. Red, okay, yellow, and blue. Hmm. Which row matches a region of the electromagnetic spectrum to one of its uses? Okay. Do we use gamma rays in intruder alarms? Hmm. لا. No. Infrared in satellite television? Infrared in satellite television? No. We use the microwaves in satellite televisions. Microwaves in mobile cell phones? Microwaves? Yes, we do use microwaves in cell phones and satellite televisions. Yes, this is correct. Radio waves in sterilizing food? No, this is wrong. So the only answer would be C again. Okay. Paper one, it's very easy because you can emit you can emit three of the four answers. Okay, usually you can emit three of them quite easily. Hmm. Okay, a ship sounds its horn when it's 790 meters from a cliff. A passenger on the ship hears an echo 4.8 seconds later. What's the speed of sound? How can I find the speed of sound? This is an echo. Ah, this is an echo. How can I how can I find the speed of sound in an echo? Speed equals a 2 distance over time. Speed of an echo is what? 2 distance, not distance over time. It has to be 2 distance over time. 2 times 790 divided by 4.8. So it has to be about yeah, 2 times. Yeah, this is quite easy. It would be B. Yes, it would be B. 2 times 790 divided by 4.8 would be around B. Okay, good. Which row? Again, Shoaib, whenever we have an echo, you have to use 2 distance over time. You cannot just divide distance over time. This would be definitely wrong. Which row gives the metal used to make the core? Yeah, core of an electromagnet. Can it be steel? No, cannot be steel. It has to be iron. Why? Because it's a temporary magnet. Iron is a temporary magnet. Hmm. Yeah, easy. Question 24. Hmm. A plastic rod. Okay, they are not rubbed together. The rod becomes negatively charged. The rod is now negatively charged. So the cloth, if the rod is negative, so the cloth has to be positive. The cloth is now positive. Why? Because the rod is negative. What are the particles that move? Definitely electrons. It's quite easy. The only particles that are moving are the electrons. Yeah. A power supply of electromotive force 12 volts is connected to 3 ohm resistor. Which ammeter is most suitable to measure the current in the resistor? Which ammeter should we use? Yeah. Which ammeter should we use in this case? Can I find the current? Yes, I can find the current. I equals V over R. V over R, which is 12 over 3, 4 amperes. So definitely A and B are wrong. Definitely they are wrong. Uh, is it C or D? Hmm. Is it C or D? Yes, it is C. Okay. C would give a more accurate reading. D wouldn't be wrong, but C would give a more accurate reading. That's it. Okay? Okay. Yeah. Question 26. It's a really nice question. Question 26 is a really, really nice question. The cost of electrical energy is $0.25 for each of one, okay, for each unit of 1 kWh. A 220 watt heater is switched on for 48 minutes. What is the cost of this use? Okay, $0.25 for each unit of 1 kWh. Okay, what should we do? How can I do it? حلو. First of all, you need to convert the watts into kilowatts because what this is kilowatt hour. Again, this is what? Kilowatt hour. Kilowatt hour. So we need the power to be in kilowatts. How can I convert the power into kilowatts? Simply by dividing by 1000. 2200 divided by 1000 is 2.2 kilowatts. Okay, that's first step. 2200 divided by 1000 is 2.2 kilowatts. Okay, step one. Step two, for how long will I be using this device? Okay, for how long will I be using this heater? For 48 minutes. You need to convert the 48 minutes to hours. You cannot convert it to seconds. Why? Again, kilowatt hours. Kilowatt, خلاص, we found the power, and then the time is in hours. The time is in hours. So you need to convert the 48 minutes into hours. How can I convert it into hours? Divided by 60. Divided by 60. حلو. How can I find the total power? Or, sorry, how can I find the total energy used? How can I find the total energy used? Okay, it would be the power times time. What's the power? Again, in kilowatts. Power is in kilowatt. 2.2 times the time. What's the time? 48 over 60. Okay, 48 over 60. I guess it's 0.8. So, anyway, 2.2 times 48 over 60. So the total energy used in this case, okay, I don't have my calculator. Let me check. Okay, the total energy used in this case would be around 1.7, I guess. Okay, would be around 1.7. Let me check it again. Okay, I'm so sorry. Ahem. Okay, 1.76. Yes, 1.76. That's the total energy used. Can I find the cost? Yes, I can find the cost simply by multiplying 1.76 times 0.25. So if you multiply 1.76 times 0.25, the total cost would be 0.44. Total cost would be 0.44. That's it. Again, 1.76 times 0.25. Again, how did I calculate it? Very simply. How did I calculate it? The energy is in kilowatt hours. You multiply the power times the time. But the problem is that the power needs to be in kilowatts, and the time needs to be in minutes, in hours, I'm sorry. The time needs to be in hours. That's why you have to convert the minutes into hours by divide by 60, and then converting the power into kilowatts, okay, the watts into kilowatts by dividing by 1,000. When you divide by 1,000 and you divide the other one by 60, okay, you find the energy is power times time, 2.2 times 0.8, which would be 1.76. 1.76 what? Huh? 1.76 kilowatt hours. 1.76 kilowatt hour. You multiply it by the total cost, okay? You multiply it by the total cost, and this would be, okay, 0.44. Okay, that's it. Okay. Any problems? Hmm. Any problems with this question, Shabab? Hmm. Okay. The diagram shows 6 different electrical circuit components. We have 6 different circuit components. Which circuit symbol is not present in the diagram? Okay. Which circuit symbol is not present in the diagram? Huh. Do I have a resistor? Yes, I have a resistor. Do I have a voltmeter? Yes, I have voltmeter. Do I have a generator? Hmm. Do you have a generator? Which of these is a generator? Uh, this is a generator. G. That's it. It's as simple as that. It's as simple as that. A generator is a box with a G inside. That's it. Okay. So the generator would be G type. حلو. Easy. Again, um, do you have a thermistor? No, I don't have a thermistor. Okay. This is the heater. It's not a thermistor. This is a heater, not a thermistor. Okay. That's it. Okay. So the only one not present is the thermistor. Okay. Yeah. Question 28. Question 28. The circuit shown contains 3 switches and 4 lamps. We have 3 switches and 4 lamps. You still do not understand the previous question? Question. Again, which of these components is not present? Do you have resistor? Yes, this is the resistor. Okay. Do you have voltmeter? Yes, this is the voltmeter. Do you have a generator? Yes, this is the generator. Do you have a thermistor? No, you do not have a thermistor, so it's not present in the diagram. Hmm. Yeah. Circuit contains 3 switches and 4 lamps. Okay. 3 switches and 4 lamps, PQ, R, and S. Which switches must be closed to light P and R only? P and R only. You need to light P and R only. Okay. You only need these lamps. Which switches should I close? Okay. Yes. Only one. Only one. Why only one? Okay. Because the current will pass through P. Okay. And it will pass through R. Yes. Thank you. Only one. Yes. Good. Yeah. An electrical heater. يلا برافو. An electrical heater has a metal frame. The heating element is connected. Hmm. The heating element is connected to the live and neutral wires of an AC supply. The metal frame is connected to the earth wire. Which row gives the correct connections for the fuse and the switch? Again, the fuse and the switch. You must put the fuse on the live wire. Okay, the fuse has to be on the live wire. And the switch, it also has to be on the live wire. That's it. That's it, simply. Okay, the fuse, whenever you have a fuse, it has to be on the live wire. What about the switch? It has to also be on the live wire, and that's it. Okay, okay. The fuse is in series on the live wire. The switch is also in series on the live wire. خلاص. We're done with the question. It's very, very simple. Okay? Okay. Yeah. Question 30. Which electrical device uses the turning effect produced by a current carrying coil? Uses the turning effect produced by a current carrying coil. Hmm. Current carrying coil, turning effect, turning effect. So it has to move. بصوا, okay, turning effect produced by a current carrying coil. It has to move due to due to some electricity. Okay, it has to move due to some electricity passing the wire. What's the object? What's the device that moves, that rotates? What's the object that rotates, that moves due to the current passing inside the wire? Huh? The object that rotates. The output, okay? This is the output, and this is the input, okay? The output is kinetic energy and the input is electrical energy. Which of these devices has an output of kinetic energy and an input, okay? An input of an electrical energy? It would be a DC motor, okay? It would be a DC motor. That's it. Okay. What about the AC generator? Actually, it's reversed. Okay. Okay, uses, yani this is the output, not input. Okay, uses the turning effect. This is the output. Okay, what about the AC generator? No, the AC generator would have an input of electrical energy and an output of kinetic energy. Okay, the AC generator would be the other way around. The relay, no, it uses the magnetic effect. It uses what? The magnetic effect. Okay, not the turning effect. It uses the magnetic effect. Okay, the transformer, you can say it uses the magnetic effect as well. Okay, but again, the DC motor is the device, is the electrical device that uses the turning effect to produce, okay, I'm sorry, that uses the, okay, produced by a current carrying coil. It uses the current carrying coil. It uses the current carrying, it uses the input, it uses the current to produce what? To produce some motion, to produce some force. Okay, how to produce this force? By the current, which is the input to the motor. Okay, you can just read it the other way around. You can simply read it the other way around. Okay. Hmm. Relay, yes, yes, they are magnetic effect. Okay, the relay and the transformer can use the magnetic effect, but the DC motor uses what? It uses the current to produce. Okay, it uses the current to produce what? To produce a turning effect. Okay, okay. Four appliances all use an electric current to operate. Four appliances use an electric current to operate. Which appliance uses the magnetic effect of the current? I just said it. Okay, I literally just said which appliance uses the magnetic effect of the current? Is it the heater? Huh. Is it the light bulb? I just said it is a relay. So the relay uses the magnetic effect. Okay, I hope we're clear now. I hope the relay is clear by now. Ah, a question, yeah. A student makes four different types of transformers. She counts the number of turns on the primary and the secondary coil. She labels each transformer as either step up or step down. Which row shows correct labels? Primary, secondary. Five and five. Yani, you didn't increase or decrease, so this would be wrong. Uh, 10 and then 5. What happened? It decreased, so it's not step up, it's step down. 10 and 20 should be step up. 20 and 10 step down. Yes, this is good. The number of turns has decreased, so this is a step down transformer. Hmm, Quite easy. How is electricity transmitted over large distances and why is it transmitted this way? How do we transmit electricity over large distances? Transformers. What do we do with this electricity? How can I transmit electricity over large distances? What do I do to the voltage? Huh? What do I do to the voltage? Can I increase or decrease the voltage? I always, huh? Increase. Yes, I always increase the voltage. Why do I increase the voltage? For safety? No, it's actually more dangerous. Okay, when you increase the voltage, it's actually more dangerous. We increase the voltage. Why? To reduce the energy lost. Yes. Why? Because when the um, voltage increases, what happens to the current? The current decreases, and when the current decreases, what happens? The heating effect, okay, the heating effect in the wires decreases as well. Okay, the heating effect in the wire decreases as well. When the heating effect decreases, okay, it's better for the energy lost. Okay. Mm. You decrease the energy, the amount of energy lost. Yep. An atom of an element contains electrons, neutrons, and protons. Yalla. Which particles are found inside the nucleus? Quite easy. A piece of cake, yani. Can I find electrons? No, no, no. We only find neutrons and protons. Hmm. What's the nucleon number? Nucleon number. Nuclear number. That's the number. Ah, 36. Why is it 36? It has to be 30. I guess you meant 35. Yes, it is 35. Hmm. 35. Yeah. What is a major source of background radiation? What's a major source of background radiation? Huh? Really interesting. What's a major source of background radiation? Yes, definitely. A. Yes, A. Nuclear power stations don't produce background radiation. A. Yes, cosmic rays. Can I find the half-life of this source? Yes, this question has been repeated more than once. 1000 divided by 2 is 500. Horizontal and then vertical line. So it would be 5 years. Very simple. Hmm, very simple. Which row about the orbits of Earth and Moon is correct? The orbits of the Earth and the Moon. Hmm. The approximate time for the Earth to orbit the Sun. Hmm. The Sun, definitely 365. Uh, the approximate time for the Moon to orbit the Earth is 30 days. Yes, it is D. Okay, the Moon rotates around the Earth in 30 days, sometimes 28, sometimes 29, okay, days. Which description of a galaxy? Again, a galaxy. Which description is correct? Collection of billions of stars. Okay. Collection of gaseous planets orbiting a star. No, this is a solar system. Rocky planets and orbiting a star. No, again, a solar system. All of the stars that exist. This is the universe. Collection of billions of stars. This is a galaxy. Light from distant stars is redshifted. What is redshift? What is redshift? A decrease in the wavelength, or is it an increase in the wavelength? Yes, it is an increase in the wavelength caused by a star moving away or moving towards the Earth. Moving, yes, moving away, definitely away from the Earth. Okay, that's it.